Welcome back, students. Good morning. It's a pleasant morning. In this video, we are discussing one example based on a radius of a curvature on polar form. Show that for the curve r raised to n is equal to a raised to n sin n theta. For this, the radius of a curvature rho varies inversely as r raised to n minus 1. Rho varies inversely as r minus 1 means you need to show that inversely means which is 1 by r raised to n minus 1. So rho varies inversely as 1 by r raised to n minus 1. So we need to show that rho is the equal to constant multiple of 1 by r raised to n minus 1. That's enough to prove as rho varies inversely as r raised to n minus 1. For this, we have an equation r raised to n is equal to a raised to n sin theta. You can take logarithm on both sides for this. Okay. Log of r raised to n is equal to log of a raised to n into sin n theta. So apply laws of logarithm here. Log m raised to n. M raised to n is n log m. N log r is equal to, here you can apply log mn. Log mn is log m plus log n, that is log a raised to n plus log sin n theta. Next, you can differentiate r with respect to theta. Okay, differentiate r with respect to theta. You will get n is a constant. Differentiate log r. Differentiation of log r is 1 by r into dr by d theta is equal to a raised to n. A is a constant, log a raised to n is constant. Differentiation of log a raised to n is 0 plus log of sin n theta is 1 by sin n theta. Again sin n theta differentiation is cos n theta. Again n theta differentiation is n. We can cancel n and n here. Okay, fine. Now, dr by d theta is equal to r1. Okay, and you cross multiply r to the right side. Okay, this is cos n theta by sin n theta is cot n theta. So that is r times of cot n theta. Okay, next we have to find out second derivative. Why we are finding second derivative and first derivative? Because we have a formula here. Just can concentrate. Rho is equal to r square plus r1 square whole raised to 3 by 2 divided by r square plus 2r1 square minus rr2. So for this purpose, we are finding r2. Again apply UV rule. Differentiation of product of two function. First function, differentiation of cot n theta is minus cosecant square n theta. Again n theta is n plus second function is cot n theta, and differentiation of r is r1. That is r is dr by d theta or just r1. You substitute r1 and r2 in the radius of a curvature in polar form. That is r square plus r1 square whole raised to 3 by 2 divided by r square plus 2r1 square minus rr2. So keep it r square as it is. Okay, plus r1 square is r cot n theta. R cot n theta whole square is, which is r square cot square n theta whole raised to 3 by 2 is as it is, divided by r square, keep it as it is. Okay, plus 2r, r1 is r cot n theta, r square cot square n theta minus r as it is. R2 value is this total. This total means this is minus rn cosecant square n theta plus r1 cot n theta. Okay. Now, calculate. Just we are simplification. R is equal to, in these two we have r square common. we will get 1 plus cot square n theta, again whole raised to 3 by 2 as it is, divided by r square as it is. This total term is as it is. We can multiply here. Minus minus plus, r into r is r square n, or nr square cosecant square n theta, minus plus minus r into r1 is r1 cot n theta. Okay. Next, which is equal to, just look at what I am doing is, this is r square whole raised to 3 by 2. R, because these are the product of two terms, r square whole raised to 3 by 2 is 2 and 1 by 2 get cancelled, you will get only r cube, or you can also write here. Okay, I am writing somewhere here. Okay, you have r square whole raised to 3 by 2. So this will become r raised to r square into, which is 3 by 2, one of the laws of indices, which is r cube. So this is r cube. Similarly, this will become 1 plus cot square n theta is, by using the third identity of trigonometric function, it will become cosecant square n theta, again whole raised to 3 by 2 is cosecant cube n theta, by using this. Okay, fine. Now r cube cosecant cube n theta, keep it as it is. In the denominator, r square plus 2r1 square cot square n theta minus r square cot square n theta becomes. So how this will term get, by using r1 cot n theta, you have to substitute r1 value here. What is r1 value? R cot n theta. You substitute here r cot n theta. R into r is r square, cot n theta into cot n theta is cot square n theta. Okay, so by using this, it will become r square cot square n theta. So 2r1 square cot square n theta minus r square cot square n theta become just r square cot square n theta. This term is as it is. Next, in the denominator, we can take r square common. You will get 1 plus cot square n theta, plus here if I take r square outside, you will get n cosecant square n theta. Now rho is equal to, here I have written r cube as r into r square get cancelled. Here r remains, r into this cosecant cube can be written as cosecant square n theta into cosecant n theta, divided by, this is 1 plus cot square n theta is again cosecant square n theta, plus this is cosecant square n theta. So in the denominator, you can take cosecant square n theta common, you will get 1 plus n here. So cosecant square n theta get cancelled. Here you have cosecant n theta remaining, r into cosecant n theta divided by 1 plus n. So now we are using, what is the value of cosecant n theta? So cosecant n theta is obtained by using the given equation. You have r raised to n is equal to a raised to n into sin n theta, right? You can write the reciprocal of sin n theta. Reciprocal of sin n theta is 1 by cosec n theta, right? So left side is r raised to n by a raised to n as it is. Okay, you cross multiply here. Here you will have cosecant square n theta, and here it is a square divided by r raised to n. So totally you need to substitute cosec n theta as a raised to n by r raised to n. Okay, now cosec n theta is a raised to n by r raised to n. Okay, so you bring r to denominator. Okay, it will become r raised to minus 1. So this r raised to minus 1. When bases are same, powers are added, r raised to n minus 1. Here a raised to n divided by 1 plus n or n plus 1 as it is. So a is a constant, n is a constant. This is totally a constant multiple of 1 by r raised to n minus 1. Okay, so rho is a constant multiple of 1 by r raised to n minus 1. Again, this is in terms of inverse. So therefore, rho varies as 1 by r raised to n minus 1, or radius of a curvature varies inversely as 1 by r raised to n minus 1. Thank you so much for watching. We will meet in the next video. Thank you so much.